Yes, we are going to look at electric cells. You understand? So, whenever you hear electric cell, the first thing that comes to your mind is what? Battery. It's what? Battery. When you use your touch light, you have to put battery, is it not? When you are using your phone, you need battery, is it not? When you are driving your car, you need battery, is it not? So, plenty things need battery. So, how do you make a battery? Battery is simply the connection or the combination of two or more cells. Two or more cells. You understand? So whenever we are talking about electric battery, electric cells, know that we are talking about what? Batteries. Because when you have more than one cell, you have a what? Battery. Is that clear? So electric cell is a device used to generate electric what? Force needed to move the electrons through internal or external what? Circuits. You understand? We say that for you to have current, you need a cell, source of charge. So electric cells are source of what? Charge. They produce charges. And when the charges are moving through the circuit, they generate current. They generate what? Current. So it can move through internal or what? External what? Circuit. We have different examples of cells. We have what we call simple or voltaic what? Cell, which is the first one we're going to learn. Simple or voltaic cell. We also have Daniel cell, we have Leclerc cell, and we have what we call accumulators. Is that clear? There are two classes of cells that we have. You understand? We have the primary cell and the secondary cell. The primary cells are those ones that cannot be recharged. You understand? If the car battery, if it runs down, you will take it to a mechanic to recharge it, is it not? Because it is a secondary cell, it is accumulator. But the ones that you cannot recharge, they are known as what? Simple cell or primary cells. Is that clear? So we're going to take these cells one by one. Number one, we'll take voltaic or simple cell. Voltaic or simple cell, they have structures like this. They have structures like what? Like this. They have two electrodes. Two what? Two electrodes. Positive and what? Positive and what? So if this one is the copper, this one will be the what? Zinc. So voltaic cell is made up of positive copper electrode. Positive what? So this one is what? Positive. And negative electrode. Negative zinc what? Electrode. Is that clear? Both of them are dipped inside what? Dilute tetraoxosulfate what? 6 acid. So they are dipped into what? Dilute tetraoxosulfate what? 6 acid. So for you to have a voltaic or simple cell, you need to have two electrodes, copper, which is positive, zinc, which is negative, dipped into what? Dipped into dilute H2SO4. Is that clear? So yeah, dilute tetraoxosulfate 6 acid. Dilute H2SO4, or you say yes, or you say dilute tetraoxosulfate 6 acid. Is that clear? So that is the electrolyte that you put the electrodes inside in order for you to generate what? Current. In order for you to generate what? Charges. Is that clear? So you have electrons will move in this direction. Electrons will move in what direction? This direction. They are moving from the negative. You know electrons are negatively charged. They are moving in this direction. But the conventional direction of current is from what? Positive to what? Negative. So you have the conventional flow of current. Is that clear? You have the conventional flow of current in the reverse what? Direction. In the reverse what? Direction. So whenever you're talking about simple voltaic cell, you're talking about a cell that consists of a positive copper electrode and a what? Negative zinc electrode dipped inside what? Dilute tetraoxosulfate what? 6 acid. Is that clear? Now, there are what we call defects of simple cells. Simple cells, they don't last long. They don't do what? They don't last long. Like the battery car, you see that the battery lasts very long. But simple cells, they don't do what? Last long. They don't do what? Last long. Why don't they last long? Because they have defects. And what are these defects? There are two types of defects of simple cell. We have what we call polarization and local action. We have what we call what? We have polarization and what? Local action. They are the two defects They are the two things that make simple cells not to do what? Last long. And what is polarization? Polarization is caused due to the formation of what? Hydrogen bubbles on the copper electrode. Can you see this copper electrode? If you start using it, there will be hydrogen bubbles formed around this copper electrode, and that will cause polarization. And how can you correct it? How can you make this thing not to be happening? You can correct polarization by adding the polarizer. You can correct polarization by adding what? The polarizer. And what are the examples of the polarizer that you can add? Copper 2 sulfate solution. Or you can also add iron chloride solution. You can also add what? Iron chloride solution. So another correction for polarization is by doing what? Giving the copper electrode a rough surface. Make sure that the surface of this copper electrode is what? Rough, in order to prevent polarization. So two defects of simple cell are what? Polarization and what? Local action. So what is local action? Local action is caused due to the presence of impurities in the zinc electrode. Can you see the zinc electrode? If this zinc electrode is not pure, it will have impurities. Is that clear? And these impurities are going to create tiny cells, thereby causing the dissolution of zinc. Zinc will be dissolving. Instead of staying static and acting like an electrode, it will be doing what? Dissolving. Once it's dissolving, it will cause what we call what? Local action. Due to the presence of what? Impurities in the what? Zinc electrode, which set up tiny what? Local cells at the zinc surface, causing its what? Dissolution. So how can you check, how can you correct local action? You can correct local action by what? Cleaning the impurities in the zinc with dilute H2SO4. With what? Dilute H2SO4. You clean those impurities. Then after cleaning the impurities, you have to dip the copper into what? Into mercury. You have to dip it into what? Mercury. So that you form what we call what? You have to dip the zinc, not the copper, zinc into mercury, so that you have what we call what? Zinc amalgam. Zinc what? Amalgam. This thing will prevent the formation of what? Local action. So after cleaning the zinc with diluted H2SO4, do what? Dip it into mercury to form zinc amalgam, and that will prevent local action. Is that clear? So that's what we've learned today. Electric cells, like I told you, every battery that you have, whether